So in this demonstration, I wanted to go over a normal SD-WAN implementation that doesn't use any sort of BGP. The primary goal of this is just going to show you how tunnels are established using either external interfaces on the device, or if you were to have your own IP block that has an autonomous system number registered for BGP. That way you can use the routing protocol BGP to dynamically update your ISP circuits. So however many circuits it's going to be, you would dynamically send them, let them know that you are whatever subnet that you purchased, whatever public IP network you have. This way you could establish tunnels to your public IP instead of your interfaces, and you don't have to set up multiple tunnels. So in this instance, our public IP is going to be 172.19.00.24. It's not public, but in this lab, that's what I have it set up as. Our interfaces are going to be these two subnets, one for each interface, one that goes down to Washington, one that goes out to Montana. We're going to partner with this FortiGate on the far right. Its internal IP address on its internal network that we're going to test with is 10.0.1.0, and then its external facing interface is 172.18.30.4. There's no redundancy or anything on this. This is just to show like one tunnel to another location. This could be for site-to-site tunnels. This could be for point-to-site tunnels. It can be for anything else. It could be for like web servers or any other thing that you might be hosting that you need that public IP address for. In the kind of conventional setup of just using SD-WAN on this SRX device, you would be pointing this FortiGate at both or a single IP address. It kind of depends how you have it set up. You might have one tunnel that's using a primary IP and a secondary IP, so that way it'll fail over to the secondary IP. You might have two separate tunnels set up at the same time, one to each, or you might have an instance where you have a device where it's not actually going to dynamically update this, and you have to go into this FortiGate or whatever device it is, set up the target IP address for that tunnel, or change it based on whatever this failed over to. I'll kind of show you how this is going to work. Right now what we're doing is we're advertising this subnet to both of our circuits. We're not really worried about what our external interface IP addresses are. And by doing that, if one of these circuits were to go down, since they use BGP in the background too, let's just say like this next hop. So let's say Montana was our first hop, like our default route coming in. If Montana were to fail, this North Dakota router or whatever would know, hey, Montana's down, but Washington has a way to get to this. So that way it would go over your second circuit instead of just your initial circuit without having to do any sort of changes on your end. The main thing that this is going to take, kind of like what I said at the beginning, you would have to purchase or lease a public IP block. And if you purchase it, you can just register with an autonomous system number with something like Aaron or another authority of internet. If you're leasing it, you'd probably have to reach out to the ISP as well, just to let them know kind of like what you're wanting to do. And then they'll either register that with Aaron or you might have to. I forget exactly how that works, but those are two requirements. You do need to have autonomous system number registered since it's going to be an individual unique number, and you'll have to have that public IP block. So we're showing these. What I'm going to do is I'm going to pull up the FortiGate real quick. We can see that this internal interface matched what we're talking about. Its internal interface is 10.0.1.3. That's what we're going to try and ping from the backside of this SRX over the tunnel. If we take a look at the IPsec tunnel itself, the tunnel that's going to the MSSP, it is pointed at 172.19.0.254. That's what we went ahead and made this one of the inside interfaces. I made it a loopback. You can kind of do it however you want, and then split that up. That's a little different than what the purpose of just showing how this is going to be redundant. And then these are just the addresses that we're allowing over the tunnel. So if I go ahead and go back to where like the actual lab here, and what we're going to take a look at is the SRX first. We're just going to do a show interfaces terse. Again, so 000, that was this 172.16 address. That's going to go down to Washington. This 1.0 interface is going to be 2.242. That's going to go to Montana. And if I take a look, here's our loopback address of 172.19.0.254. That's what we're establishing the tunnel from. And we said that the FortiGate was at 172.18.30.4, so they're showing that we can hit it, and we'll show the route as well. So Washington, Colorado, St. Louis, Nashville, Charlotte. So that's kind of the path we're taking. Any one of those kind of fail, and they'll update, and we're not worried about that in here. And if we're on this FortiGate, we'll do an execute trace route to the 172.19.0.254, which was the inside address on this MSSP SRX. We can see Charlotte, Nashville, Illinois, North Dakota, Montana. So this is actually taking a different route back. It doesn't really matter. You could change different preferences to have it take the same route. But we have bidirectional communication, as we can see. We did say that we can ping from the inside. So let's go through the tunnel. 10.0.1.3, I think was what it was. And if I do get system interface, we can see, yeah, 10.0.1.3 was what we're seeing. So we can see we got traffic through the tunnel. If I were to trace route from this device to the 10.0.1.3, we can see we're going straight through to our default gateway, and we don't have anything else that is ending up out there, and I'm not able to resolve this. I need to set that up if I wanted to have that resolve. So we can see that we can ping through the tunnel. Everything's set up. Let's see what way we're actually going. So if we take a look at the route on the SRX, we're actually going out 000. So right now we're going down to Washington. So in this case, we're going to simulate Washington failing. What we won't see then is we won't see, yeah, we actually will see this update. So, well, no, because it's going to continue to go over Montana. So this probably won't change. So in order to simulate Washington failing, what we'll do is we'll pull up the Washington router, go into configuration mode. We're going to go ahead and set the interface range as 00 through 6. And I'm just going to shut all those interfaces down. So what that's going to do is that's going to, and this needs to update. So if I do show IP or show services IP monitoring status. Okay, so now we can see that this probe of ISP DNS failed, and it went ahead and applied the new route. So if I do a show route, this time we can see that we're going out 10 instead of 00. And it's got a lower metric or administrative distance that we can see over there. If we scroll up, it was just going out 00. So if I ping that from our 172.19.0.254, which was our IP, I can still go out. And if I were to trace route that from the source of 172.19.0.254, we can see now we're going Montana, North Dakota, Illinois, Nashville, Charlotte, and then our next hop would be the FortiGate itself. So we see that there's communication going across, and we can see that, oops, let me go to the actual ping. And we can see we can still ping over the tunnel. This was pretty much sub-second failover. In order to do that, you're going to have to run BFD, bi-direction forward detection, on top of BGP, which is pretty simple to do. I can kind of show that if I needed to. But nothing had to be changed. We didn't have any multiple IP addresses. We saw that when we looked at the tunnel itself, it's only going to this 172.19.0.254 address. So the routing protocol pretty much handled everything, because the only thing that we're doing is we're just telling both of these ISPs that that subnet lives here, and then we can do whatever we want. This kind of allows, if your external IP addresses were to change, you'd still have to reset up that BGP session, but your configuration on your end really wouldn't change outside of just updating that dynamic routing protocol.